In this lab, we used the Charpy impact device to test the high strain rate of steel material at different temperatures. The Charpy impact device is composed of an arm with a mass attached at the end that is able to swing freely. Also attached to the device is a scale and needle that is moved by however much force it was needed to break through the material being tested. The scale in which this device reads is in Charpy, which can also be equivalent to 2.5 joules. The type of test specimens that are used in this device are rectangular with a slit that is able to control where the specimen breaks as the mass hits it. To begin testing, we lock the arm in a vertical position waiting to be released. For our first test, we heated our specimen to roughly 150 degrees as checked by infrared thermometer. Then placed our specimen on the test area. Once the specimen was placed in the test area and the high-tech security doors have been closed, all that was left to do was pull the release handle and allow the mass to swing down. You can see the specimen breaking right as it hits. For this test, we had a reading of 4.5 Charpies. Next, we submerged our specimen in a cold bath and then reset the test. For this test, we got a reading of 1 Charpy, which is to be expected from the much colder material being more brittle. For our final test, we took a specimen at room temperature and placed it in the test area. And once again, we reset everything back to start and then pulled the release handle. The reading we got for this test was 2.5 Charpy, which is to be expected right in between the hot specimen and the cold specimen. The hot is above all the others because it has a higher elasticity due to the temperature. This effect can be greater seen by looking at the samples and how they broke. The high temperature sample looks more like it has been torn as opposed to snap, whereas if you look at the room temperature one, it has much more of a clean break, as well does the cold baths. This clearly shows that the higher the temperature of the sample, the more energy it can absorb because of its increased elasticity. And thank you for watching.
Yeah. I dropped my gloves on something. The one in 1,000. Did that work out? Yeah.